is all about equivalency, right? When you do radical reduction, the rule is this, and a lot of times we don't write that variable, but it comes down to we can break numbers into their factors. So like 20, I like finding the perfect squares. It's like 4, 9, 16, 25, 36, and so on. So if I start there, I see square root of 4 times square root of 5 would make square root of 20. But I know the square root of 4 is the whole number 2. 7 times 2 is 14 square root of 5. And then I start down the process. Now, 32 is one of those numbers. It would help if you saw 16 and 2. Most students don't see that, so we'll start with 4 and 8. So again, I get 5 times 2, so then the square root of 8 can break down to 4 times square root of 2. Again, radicals. I get 10 times 2 times square root of 2. And I get 20 square root of 2. So far, no like terms. Square root of 5 square root of 2 aren't the same. 45, we should catch as square root of 9, square root of 5. And I get 6 square root of 5. Now I have some like terms. 180. All right. Again, I think the one I would personally see is 9 and 20 first.
Tyler Parker to the office, please.
I get square root of 4, square root of 5. And I get negative 6 times 2 square root of 5. I get negative 12 square root of 5. I have like terms, 3 of them. 14 plus 6 minus 12 is 8, right? So 8 square root of 5 minus 20 square root of 2 is the answer to that first, or that the simplification of that first expression. All right? All right, and again, for the next one, I'm going to do all the perfect squares, all right? So 18, I'm not going to pick 3 and 6. That would work, but the easier selection is 9 and 2. And that gives me 3 times 3 times square root of 2, and that gives me 9 square root. And I work all the way down the terms. Minus, the perfect square out of 8 is 4. And I get 14 square root. If you like terms already, we'll deal with them at the end. I don't want to pick 5 and 10, it works. But you want to see 25 goes into 50. And 2. And this is 3 times 5 times square root of 2. This is 15 square root of 2. Last one, this is one that, again, the old math teacher here knows well. 32. I see 16 and 2. And that's simply by practice. If you do 4 and 8 like we did up on top, it'll work. But I know 16 times 2 is 32. They're both factors. Square root of 16 is 4. And again, now all 4 terms are like terms. 9 minus 14 is negative 5. Plus 15 is 10. Plus 4 more is 14 square roots of 2. All right. So we want to reduce. You want to stay by terms. All right. And you want to look for perfect squares. And it's not that 6 times 3 won't get you there. It will. But when you see 9 and 2 make 18. 18 is the square root of 9 times the square root of 2. The square root of 9 is equivalent to the whole number 3. So now, and we also know 2 times 3 is equivalent to 6. I just completed simplifying the first term. I go to the second term. And again, 8 and 3, 2 and 12, those would work. But if you catch that, 4 and 6 make 24 also. 4 is a perfect square. It just makes our lives easier. Either way, you'll come up with the same term. If you really want to practice this, work it one way, then work it the other. The last one is a little hard to see. I would try 4. 4 would not come out of 98. You try 4. Because I would be thinking, hey, it's even. Let's see if the square root of 4 comes out. Then I try 2, and it happens to be the square root of 49, which is a perfect square. That is 7.
Isn't that convenient?
That is convenient. That's why these problems are set up this way. Like terms. Now, you can look at 6. It is a square root of 2 times square root of 3. But those do not escape out of the radical, so I leave it as 6. I see like terms in these two. 6 minus 42 is negative 36. Square root of 2 minus 8 square root of 6. That is the answer to the first one.
What if I wrote it with the two opposites?
Okay? Does not matter which order you put it in. So if you do it the other order like this,
Yeah.
this is exactly the same.
Okay.
All right? All right, the next one, same thing. Now, I'm going to do this a little longer. Listen, 32. You should start seeing this as 16 times 2. If you don't, and a lot of times new students don't see it that way. They see this. All right? Well, the square root of 4 is the whole number 2. But square root of 8 breaks from the square root of 4, square root of 2. That makes this whole number 2. 2 times 2 times 2 is 8. So 8 square roots of 2 is the first term. Second one, you should learn your 1, 2, 3, 4, 5 to the cubic. This is 5 cubed, so I know this is also square root of 25 times 5. So I know that's the whole number, 5. And your second term should be 20 square roots of 5. Your final term, I check 25 right away. Instead of 5 and 10, 25 comes in, I get 2, so I get plus 6 times 5, square root of 2, so 30 square roots of 2. All right, now I have square root of 2, square root of 2. I think I can write this as 38 square roots of 2 minus 20 square roots of 5, or I suppose I can write it this way.
Is that the ugly way of writing it?
I don't know. I don't think it matters. I like to have a positive number first, given the choice.
Oh.
But it doesn't matter. It really doesn't. Depends on the application. All right.